So the job that I'm going to be talking to you about in this video is going to be crystallography. The way that it relates to the units that we learned in this course is that it relates to structures and properties unit because there's a lot of emphasis on ionic bonding and the forces that exist in the atomic structure that make up crystals, and that's a key part of the job and the learning experience. I'm just going to give a brief history of crystallography. So since ancient times, scholars and scientists have been intrigued by the beauty of crystals, their geometric shape, and the variety of colors that they come in. So these early crystallographers used geometry to study the shapes of crystals in the natural world. And then in the early 20th century, it was realized that X-rays could be used to see the actual structure of matter in a crystal in a non-intrusive manner. So this marks the dawn of modern crystallography when X-rays were discovered in 1895 because they realized that using the beams of light that comes from X-rays, they would scatter the atoms in a crystal, and this is what allowed scientists to develop the atomic structure of a crystal. Basically, crystallography is the science that examines crystals which are found everywhere in the natural world, from salt to snowflakes to gemstones. And crystallographers use the properties and inner structures of crystals to determine the arrangement of atoms and to generate knowledge that is used by chemists, physicists, biologists, and other professions. So within the understanding of crystallography, it was a primary force in driving major advances in detailed understanding of materials, synthetic chemistry, the understanding of basic principles of biological processes, genetics, and has contributed to major advancements in the developments of drugs for numerous diseases. So as a science, crystallography has achieved 28 Nobel Prizes, which is more than any other scientific field. So crystallographers will use things like X-rays, neutrons, and electron diffraction techniques to identify and to characterize solid materials. So this is an example of using microscopic imaging to see the atomic structure of a crystal, and then this is an example of an X-ray fluorescence, which is how they see the atomic structure because they bounce beams off the atoms inside of a crystal, and it will diffract the beams, which will give an idea of where the atoms are once they deflect off an atom. This means there's not empty space there. So now we'll be talking about the education that you need to become a crystallographer. So basically, laboratory technicians, which is the most basic level of crystallography, will require a bachelor's degree in either chemistry, biology, physics, geology, or another type of scientific field. And then research positions usually require master's degree or a PhD doctoral degree. And then graduates who want to pursue degrees in academia or further research will usually require to do internships for 1 or more years, and they will probably have to do multiple levels of this internship. And then once you want to progress and become maybe a director of a laboratory, you'll usually have to do fellowships with professors, or you have to do fellowships with people who are already in that position for multiple years before you can take that advancement in your career. So now I'm going to be talking to you about the responsibilities or the work duties that crystallographers will have to perform in various jobs. So there is conducting laboratory research in government institutions, biological, nonprofit, or industrial institutions. Then there is characterizing new compounds and materials for patent claims. Then there's helping develop synthesis processes by monitoring product formation, purity, and identity. Then there's to verify the quality and purity of formation materials for things like building and manufacturing. Then there is characterizing mineral formations of human and geological cause processes. Then developing computer models and simulations of physical and biological phenomena. Then there's analyzing forensic evidence to use in criminal investigations, counterfeit investigations, and to track down the causes of industrial accidents. Then analyzing the historical or archaeological artifacts and to authenticate and conserve works of art. to grow crystals for research and manufacturing purposes, to develop new software and hardware capabilities for data collection and analysis, and then finally to provide customer service as an employee of a service laboratory or a sales or service representative in a manufacturing industry. Next, I'm going to be talking to you about various trainings that would be required for different jobs in crystallography. So a lot of the times in crystallography, you start off in a laboratory that has a lot of different types of equipment that is computer based or things like x-rays, and you have to learn how to maintain them, how to properly use them, and if necessary, how to repair the equipment, especially because it is constantly changing as technology advances. As well, you are constantly working with different types of chemicals, and you have to be trained on how to properly use them and how to dispose of them properly. And a lot of the time, students come to these laboratories, and you usually are responsible to train other students on the safety practices and procedures in your own lab. Furthermore, crystallography is a very computer intensive field, and you have to be trained on new methods of data collection, analysis methods, on software packages, and on computer visualization capabilities. As well as I mentioned, you do deal with equipment such as x-rays, which emits dangerous radiation through things like neutrons and high energy electrons. So you have to be trained on how to properly act around radiative equipment. Working conditions in crystallography basically just depend on the field you are working with. So if you are working in a laboratory and conducting research, it is a very flexible job because it depends on the project that you are working on or the length of the research that you are doing. So it can be a 9-to-5 job where you just come in and finish your research duties for the day, but it can depend. If you need to spend more time doing research, you would stay longer. If it's a shorter project, it wouldn't require as much time. And a lot of the times, a lot of the people are very invested in the research they do, so they usually do spend longer hours in the lab, and they even do come in on weekends. But if you're working in the field as a sales or customer service representative of your laboratory or industry, then you are basically doing a job where you're going to different doctors' offices and pharmaceutical companies. So again, it's not very much a 9-to-5 job. It's just what kind of interviews you have lined up for the day. It can be 2, it can be 1, it can be 3, where you're going to different companies and giving presentations on your services or products. And then finally, there is being in a classroom, which would be most likely if you have a PhD and you are a university professor, and this would be the most regular job where it would be kind of a 9-to-5 job where you would be teaching classes throughout the week and then possibly night classes on the weekend. Next, I'm going to be talking about the personal skills and attributes that you may need in crystallography. And again, these skills and attributes vary on the field that you are doing, but they may include things like problem-solving skills and an interest in solving basic and applied research problems. Then there is critical thinking and analytical skills to help design experiments, troubleshoot processes, and analyze data that's collected. Then there's written and oral communication skills that you need to use to explain your research findings, as well as to explain your results to scientists and even non-scientists. Then there's computer skills that will help you with the familiarity of computer modeling and data analysis. Then there's skills in adapting and integrating computer software to help solve new categories of problems. Then there's the ability to visualize structures in 3 dimensions, as this is the basis of X-ray crystallography. Then there's crystal growing capabilities to help with crystal research. And then finally, instrument maintenance, operation, and development skills. In crystallography, most people will usually start off for several years just working regularly in a laboratory, and then later on a lot of people just specialize in the field that they're studying in crystallography. So this can include a job such as a crystal growing specialist that uses a variety of techniques to produce crystalline forms of compounds for use in research or manufacturing. And they may be experts also in working with hard to crystallize materials, or they may grow crystals for exacting specifications for use in computer chips, solar cells, optical components, or pharmaceutical products. As well, a lot of the times, crystallographers will specialize in the field of pharmaceutical or biochemistry, and basically this includes altering proteins and other structures, including viruses that are found in the body, into crystalline form so that they can be used to produce things like drugs. These people will often also have to be able to provide detailed descriptions of the crystalline forms of these drugs so that they can use this as evidence when they're developing patent claims for their drug or for their company. Then there's people who are actually developing the instruments and the technologies that are being used for crystallography, such as I mentioned. A lot of people have to develop new crystallography computerization techniques, which includes things like developing software to produce 3D models online and also developing new x-rays that can be used for x-ray diffraction. Then finally, there's the ability to go into a forensics unit in criminal investigations in a police department. So basically, what crystallographers will do is they can go to the scene of the crime so that they can identify different powders or materials that are found there. As well, they often use crystallographers to help in counterfeit investigation. Now, some interesting facts about crystallography. So the word crystal actually comes from the ancient Greek, from their word kristallos, which means cold and drop. So basically, the ancient Greek thought that crystals looked like ice, so that's why they wanted a meaning that emphasized the cold part. As well, a lot of crystallography in the past centuries has helped develop very important mathematical concepts, such as Niels Stenson, who discovered the law of constancy of angles for the faces of different crystal specimens of the same species. As well, the mathematical concept of repetition that occurs in lattice structures, which is very important when studying ionic bonding in chemistry. As well, there is the idea of cocoa butter, which is one of the most important ingredients in chocolate. And basically, it actually crystallizes in 6 different forms, but only one of these forms melts tastily in your mouth. So a lot of the times, this form that we find so tasty is not actually very stable. So if you keep chocolate in your mouth for too long, it will start to go into a more stable form that's actually very sandy and coarse, and it will have a very weird feeling on your tongue. And as well, if you keep chocolate stored for too long, it may become to form a white filmy residue that's actually the chocolate recrystallizing. And this is why a lot of the times chocolate makers depend heavily on crystallography, because they have to make sure they can achieve this one tasty form of crystallization and that this form can last on the shelves. So as I mentioned before, the discovery of the X-ray in 1895 made a huge significance to crystallography, and in turn this allowed for many different scientific advancements in society, which we even use today. So basically, crystals were found to be the ideal structure for studying the atomic and molecular arrangements of different matter in the universe. And this is because crystals were found to have 3 key components. One, they were solid, they were 3-dimensional, and they were built from very regular and often highly symmetrical arrangements of atoms. And due to this discovery, it allowed scientists to be able to study the chemical bonds that attract one atom to another. Biology and biochemistry are actually very important processes in studying things like healthcare and developing healthcare in our nations, and drug formation and healthcare is actually highly dependent on crystallography. And this is because drug formation is developed by people like crystallographers, because they do things like form small molecules that can actually attach to active sites of viruses or bacteria and actually make them defective. As well, by studying the structure of a ribosome, which is the most protein producing structure in our cells, we can actually form antibiotics or actually modify the structure of the ribosome to make it more effective in producing the right proteins in our body. As well, by studying the structure of bacteria and viruses that are antibiotic resistant, we can actually form new concepts that will make these bacteria ineffective and therefore the antibiotics more effective in our body. So crystallography is very helpful in areas like disease prevention, especially because it has the ability to form new drugs that are more efficient in our body and thus making them cheaper. So in places where there are poorer countries like Africa and Asia, where there's very prevalent diseases like HIV, this makes these drugs more accessible and thus making it more likely that these diseases will soon become ineffective in their countries as well. The world population is actually expected to grow from 7 billion today to 9.1 billion people by 2050. This means there is going to be even more people producing even more waste and causing a lot more damage to our already deteriorating environment. So the world is actually highly dependent on crystallographers to produce methods to eliminate or counteract the bad effects on our environment. For example, crystallographers will actually do things like analyze soils, and because there's a lot more people producing a lot more waste, it is causing increasingly saltier soils, making crops difficult to grow. So what crystallographers do is they study the plant proteins that form these crops and actually modify their structures so that they will be able to grow properly in saltier soils. As well, crystallography can help improve things like water quality because they can develop new materials that actually will purify water for months at a time, such as nano sponges and nano tablets, which purify tap water. As well, crystallography can help reduce pollution by replacing chemical solvents with green inorganic solvents that are made from ionic liquids and carbon dioxide. Crystallography underpins the development of basically all new materials in our world, from simple things like flat screen televisions and computer chips to actually developing airplane components. Crystallography can actually help with the development of new materials by establishing a material's fingerprint. So basically, a company uses this fingerprint to identify their new material, such as a drug or their new technology, as unique, and this way they can actually apply for a patent. In fact, crystallography permeates the backbone of all our industries and our daily lives, and they're constantly relying on the development of new technologies which are based off of crystallography. And this includes industries like the agriculture and food industry, the aeronautic industry, automobile, beauty care, computer, electromechanical, and mining industries that are constantly trying to move forward with our technological world. As well, crystallography can help with the development of new ecological construction materials in developed and developing countries, such as the calcium silicate board you see here, which helps with the green insulation in a home. As well, crystallography can help develop new materials that are more cost efficient when building things like solar panels, windmills, and batteries that actually reduce wastage of these products, which means it's not only helping the environment, but it's also helping greening the global economy. A phenomenon known as diffraction patterns occurs when waves pass through small, tightly held spaces on a screen. And in 1912, Max von Laue actually discovered that if X-rays were passed through a crystal, the same type of diffraction patterns would occur. And this helped develop the atomic structure of a crystal, because wherever waves would pass through, that means there's not an atom there. All the waves that are bouncing off would mean that there is an atom in that specific space. And by developing the crystal's atomic structure, this is the basis for developing all the products and technologies that I've spoken to you about today, because this is the basal unit of all matter. His discoveries actually led him to win a Nobel Prize in chemistry later on. Then the next scientist there is Louis T.J. Delbert, and basically he was one of the founding members for the Canadian Light Source Society, which is the largest crystallography research team in Canada. And he was part of the first planning meetings in Montreal, and he was the leader of the team that proposed for the production of Canada's first protein crystallography beamline, which is a type of synchrotron that produces these X-ray diffractions that I was speaking about that Max von Laue actually discovered. This highly accurate form of technology is actually helping develop even more knowledge on the atomic structure of crystals. Also coined the term the Canadian Macromolecule Crystallography Facility because he wanted this space to be produced so that more than one beamline would able to actually be produced by his successors.